Types of placental transfer. If there's diffusion, number one is diffusion, simple diffusion, facilitated diffusion, active transport, endocytosis, and exocytosis. If we see endocytosis is a process and which the process of taking in substance from outside the cell, involving the cell membrane engulfing a substance or particle in a vesicle. Its example is the phagocytosis, a type of endocytosis that involves engulfing solid material. If we see the exocytosis, the process of releasing substance from the inside the cell to the outside, involve the fusion of vesicle with the plasma membrane, increase the net membrane area and reduce membrane tension, typically secrete large molecule like protein and glycoprotein. Now, what's nutrient transfer to the fetus? So, firstly, we're going to see this role of the placenta. Its role is number one is connect the fetus to the mother, and number two is facilitate the exchange of nutrients, oxygen, and waste product. Now, what factor affecting placental transfer? If we see this maternal health, placental function, gestational age, and substances. Now, is nutrient transfer to the fetus. Number one, oxygen diffuses from the mother blood to the fetus blood. Glucose, main source for the fetus, transfer via facilitated diffusion. Amino acid is essential for the growth, actively transported. Fatty acid important for brain and cell development, pass via diffusion. Vitamins and minerals, it's water soluble, mineral like calcium and iron are transferred. Antibiotics, maternal IgG antibody provide passive immunity to the fetus. Now, what's the immune cell development in the fetal period? If we see the hematopoietic stem cell, hematopoietic stem cells. The earliest stage of fetal immune system development involved the differentiation of hematopoietic stem cell into various immune cell types, including T cell, B cell, and natural killer cell. Number two is thymic development. The thymus play a critical role in the maturation and selection of T cell, ensuring the development of diverse and functional T cell repertoire. Bone marrow maturation. The bone marrow is the primary site of B cell development, where B cell undergo differentiation and selection to become mature, functional cell. Number four is the fetal lymphoid organ. The spleen, lymph node, and other lymphoid organs also play a crucial role in the development and maturation of fetal immune system. Now, epigenetic effect of maternal diet and immunity. Maternal nutrition. The maternal diet during pregnancy can influence the epigenetic regulation of genes involving in the development and function of fetal immune system. मैटरनल डाइट प्रेगनेंसी के दौरान इन्फ्लुएंस करता है एपिजेनेटिक रेगुलेशन जीन को जो इन्वॉल्व होते हैं डेवलपमेंट और फंक्शन ऑफ फीटल डेवलपमेंट फीटल इम्यून सिस्टम में एपिजेनेटिक मॉडिफिकेशन एपिजेनेटिक होता क्या एपिजेनेटिक In biology, epigenetics is the study of heritable traits, a stable changing of cell function that happen without changing to the DNA sequence. DNA sequence में कोई change नहीं आता और ये heritable trait है और cell function change हो जाता है. Nutrient and bioactive compound in the maternal diet can induce changes in DNA methylation. DNA methylation, histone modification, and other epigenetic mechanisms that can affect gene expression. अब ये आता है मैटरनल डाइट कहते किसे हैं। मैटरनल डाइट जो है वो sorry. The maternal diet is a healthy, balanced diet that pregnant and breastfeeding women eat to support the health and the health of their babies. It includes fruits and vegetables, whole grains, proteins, dairy, fats, iron, dairy, iodine, vitamin D. Now it's going DNA methylation. Methylation. What does this mean? DNA methylation is a chemical process that modifies DNA by adding a methyl group to the cytosine ring of DNA. Now, DNA methylaphrases transfer a methyl group to the fifth carbon of cytosine residues, forming 5-methyl cytosine. This process regulates gene expression by recruiting protein that repels genes and inhibiting transcription factor from binding to a DNA. Histone modification and other epigenetic mechanisms that affect gene expression. Histone are proteins that help organize DNA into chromosomes and regulate gene activity. They are found in nuclei of eukaryotic cells in most arachidophylla. Bind to DNA. Histones are positive charged while DNA is negative charged, so they bind tightly together, form nucleosome. DNA wrap around histone to form nucleosome will like to later immune system programming. Now, these epigenetic changes can lead to long-lasting effects on the programming and function of fetal immune system, with implications for the child health throughout their lifespan. Maternal inflammation in effect in maternal in, mat, maternal inflammation and impact on fetal immunity. Number one, maternal inflammation can be due to maternal inflammation. Infections such as urinary tract infection or respiratory infection. Maternal inflammation पहला होगा जो यूरिनरी ट्रैक का होगा या फिर रेस्पिरेटरी इन्फेक्शन, दूसरा होगा क्रॉनिक कंडीशन जैसे कि डायबिटीज़, हाइपरटेंशन या ऑटोइम्यून डिसऑर्डर, ये क्रॉनिक हो सकते हैं. अगर न्यूट्रिशनल फैक्टर होगा लाइक पोर न्यूट्रिशन सच इज डाइट हाई इन प्रोसेस्ड फूड एंड शुगर, ये होगा एनवायरमेंटल टॉक्सिन सच इज एयर पोल्यूशन और पेस्टिसाइड, ये हो सकता है. इम्पैक्ट ऑफ मैटरनल इन्फ्लेमेशन एंड fetal immunity. ऊपर था मैटरनल इन्फ्लेमेशन, इम्पैक्ट क्या आता है. पहले जो होता है altered cytokine environment can affect fetal immune cell development and function. Altered cytokine जो बोलते हैं altered cytokine environment इसको अलग can affect fetal immune cell development and function. Changes in fetal immune cell population. जो fetal immune cell जो population है उसमें change आता है. एक तो alter हो गया, ठीक है, development function खराब. दूसरा है सच टी सेल एंड मैक्रोफेजेस, इसमें अल्टर आ जाता है. तीसरा है इम्पेयर्ड फेटल इम्यून टॉलरेंस. इम्पेयर्ड अगर फेटल इम्यून टॉलरेंस है ना, फेटल इम्यून टॉलरेंस इम्पेयर्ड लीडिंग टू एन increased risk of autoimmune disease. Increased risk of risk of allergic disease in offspring by promoting a Th2-based immune response. Epigenetic changes in fetus affect gene expression and immune function. Gene expression और immune function को भी change करते हैं. Now, what's the consequences of maternal malnutrition on child health? पहले आता है low birth weight, increased infant mortality and long-term health risk, stunt growth, impaired physical and cognitive development. Both defect folic acid deficiency can cause neural tube defect, weak immunity, increased susceptibility to infection, impaired brain development, lead to learning deficiency, difficulties and low IQ. Number 6, chronic diseases raises risk of diabetes and heart issues later. Number 7 is poor breastfeeding affect milk production quality. अब आता है optimize maternal nutrition for a healthy immune start. ऑप्टिमाइज कैसे करें कि मतलब हेल्दी इम्यून सिस्टम ही बन जाए. तो सबसे पहले आता है न्यूट्रिशन ड्यूरिंग प्रेगनेंसी के दौरान क्या देना है. प्रॉपर मैटरनल न्यूट्रिशन सपोर्ट द डेवलपमेंट ऑफ बेबी इम्यून सिस्टम. एसेंशियल न्यूट्रिएंट जैसे कि आयरन prevent anemia and support fetal brain development. Vitamin A enhancing the immune system and reduce risk of infection. Folic acid support health neural tube development. Vitamin D helping development of strong immune system. Protein builds tissue and support growth. Vitamin D. Yes, sir. If you are in a conclusion, maternal nutrition is cornerstone of fetal immune development. A balanced diet rich in macronutrients session. This puts into play a critical role in nutrient transfer to the fetus. If a maternal diet can epigenetically influence fetal immune development, and maternal inflammation can negatively impact fetal immune health. Optimizing maternal nutrition is key to strong immune foundation for the child. For research, you need to explore the intricate mechanism and develop target intervention. Now,